These are the notes on the area of a trapezoid. This is section 11.3. First of all, let me remind you about the definition of a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So in this diagram at the top, if these two sides are parallel, then that would make that a trapezoid. The trapezoid, the parallel sides are called the bases, and the other two sides are called the legs. And there's one other part of a trapezoid you might remember, it's going to come in handy in this lesson, is a trapezoid has a median. A median connects the midpoints of the legs. So if these are the midpoints of these two legs, and I connect them, that's the median. Okay, a couple things are true about that median. The median is parallel to both the bases, and the length of the median is the average of the two bases. So if this is base 1 and this is base 2, then the median is equal to base 1 plus base 2 over 2, or 1/2 of b sub 1 plus b sub 2. Okay, so that's the definition of a median. Okay, there's just one theorem in this section, and this theorem deals with the area of the trapezoid. The theorem says the area of a trapezoid equals half the product of the height and the sum of the bases. So in formula form, that would be area is equal to 1/2 the height times the sum of the bases. Okay? I'm going to put a box around that, and there's another formula that you need to know. Let's see why this is true, however. So if I call this base down here base 1, and this base up here base 2, then this trapezoid is really the area, the sum of the areas of region 1 and region 2, which are triangles. And you learned in the last lesson that the area of a triangle is 1/2 the base times the height. So if I draw a height here, and then for this triangle, the height would actually be on the outside. So this would be the height here. Okay. Then the area of the first region is 1/2 of B1 times H. And the area of the second region would be 1/2 of B sub 2 times H. And those H's are both the same. So the area of the trapezoid is equal to the sum of those two regions. And if I factor out the 1/2 H here, I get 1/2 H, factoring out leaves a B sub 1 plus a B sub 2, and there is that formula that we just stated in the theorem. Okay, I want to finish this up by doing several examples. So let's take a look at the first example. In the first example, we've got a trapezoid where both the legs are 8. When the legs are the same, this is called an isosceles trapezoid. And so in order to find this area, I need to find the height and I need to find the other base. So the height is going to be here, okay? And so this creates a 30, 60, 90 right triangle. So remember, in a 30, 60, 90 right triangle, opposite the 30 is half the hypotenuse, which is 4, and opposite the 60 is that side times the square root of 3. So the height is 4 times the square root of 3. Well, since this is isosceles, I can draw another height over here, and this also would be 4. And then if this top base is 8, then this part right here is 8 as well. So therefore, the total base down here would be 4 plus 8 plus 4, or 16. Okay? So now we use the formula for area is 1/2 the height, which is 1/2 of 4 times the square root of 3, times the sum of the bases, which is 8 plus 16. Okay, so the 8 and 16 is 24, and half of this 4 is 2, so I end up with area is equal to the 2 times the 24 is 48 times the square root of 3. All right, my next example involves a trapezoid, and you might think this trapezoid is kind of standing on its end. These two vertical lines are parallel, and I know that because of the right angles down at the bottom. Okay, so in order to find this area, I need to figure out what is this height. So I choose to draw the height right here. Okay, and since the angle up the top is 45, this is a 45, 45, 90 right triangle. If the hypotenuse is 3 root 2, that means each of these sides would be 3. So the height would be 3. If this side over here is 4, then this is 4 here. So this total base, therefore, would be 7. So using the area of the trapezoid again, the area is equal to 1/2 the height, which is 3, times the sum of the bases, which is 4 plus 7. So 4 plus 7 is 11. 3 times 11 is 33, and 1/2 of 33, well, we'll just leave it like that, 33 over 2. Oops, excuse me, 33 over 2. All right, next example. Another trapezoid, and this particular trapezoid is a isosceles trapezoid. I forgot to put the 30 degrees over here. So since both of those base angles are 30, that means that this is an isosceles trapezoid. And so really the only thing I'm missing here is the height. So if I draw my height in here, okay, this is a 30, 60, 90 right triangle. And if I draw another height over here, that creates another 30, 60, 90 right triangle. If that top part is 12, then this bottom part right here is 12, which would leave left over 18 for the two pieces on each side. So this would be 9, and this would be 9, right? 9 and 9 is 18, 18 and 12 is 30. So if opposite the 60 is 9, then opposite the 30 is equal to 9 over the square root of 3. Remember, you divide by the square root of 3 when you're going in that direction. So that simplifies to be, if I multiply the top and the bottom by root 3, that would be 9 root 3 over 3, or better yet, 3 root 3. So the height is 3 root 3. Okay? So once again, formula for area is 1/2 the height, which is 3 root 3, times the sum of the bases, which is 12 plus 30. So 12 and 30 is 42. Okay, so this is 1/2 3 root 3 times 42, and I'll cancel this 2 into the 42 would be 21, so therefore my area is equal to 3 root 3 times 21 would be 63 root 3. All right, and the last example says that the area of a trapezoid, a trapezoid has an area of 75 square centimeters and a height of 5 centimeters. How long is the median? So right at the very beginning of the lesson, we talked about the median. So remember, the formula is 1/2 the height times the sum of the bases. Okay. Well, the median is really the 1/2 and the B1 plus B2. So those two red circle parts represent the median. And I know what the height is, and I know what the area is. So it's 75 is equal to 1/2 of the height is 5, and the B1 plus B2. So therefore, if I divide by 5, I get 15 is equal to 1/2 of B1 plus B2, and that means that the median of this trapezoid would be equal to 15. Okay? All right, very good. That's the end of this section of notes.